In today's lesson, we'll be discussing special right triangles. The first type of special right triangles that we're going to look at are 45, 45, 90 triangles. And with a 45, 45, 90 triangle, essentially that's an isosceles right triangle, because if these are congruent, then I know my legs are congruent. So supposing I call each of these legs x, and I'll call the hypotenuse h. I want to find a relationship between the hypotenuse and the length of the legs. So the Pythagorean theorem applies, a squared plus b squared equals c squared. So I know h squared has to equal x squared plus x squared. The hypotenuse squared is the two legs squared added together. And so if I combine my like terms, I get h squared is equal to 2x squared. And I take the square root of both sides, and I get h is equal to x root 2. We can take the square root of x squared, that's x, but the 2 isn't a perfect square, so it stays under the radical. So it turns out the hypotenuse for any 45, 45, 90 triangle is always going to be the leg times the square root of 2. You're going to want to memorize this because we will use it a lot. So memorize that equation. If you need to make yourself flashcards, do whatever you have to do to memorize it. Alrighty, so let's look at some examples that use this. First, we have two examples where we're going to find the hypotenuse. So if I look at example A, it's a 45, 45, 90 based on the information they gave me. So I know the hypotenuse is going to equal the leg times root 2. So in this case, it's just 6 root 2 because the leg is 6. And that would be your answer. That quick, that easy. For example B, I'm still going to use the same equation because it's a 45, 45, 90. I know that because my legs are congruent, so my angles have to be congruent, so they're 45 degrees. So the hypotenuse is going to equal the leg times root 2. So this time, the hypotenuse is going to equal 4 root 2 times root 2. And the square root of 2 times the square root of 2 is 2, and so 4 times 2 is 8. So the hypotenuse, in this case, would equal 8. Alright, now we're going to find some legs. We still use the same formula, we're just going to work backwards to find the leg. So for letter C here, again, the hypotenuse is equal to the leg times root 2. So my hypotenuse they gave me is 9 root 2, and the leg is x. So 9 root 2 equals x root 2. We divide out the root 2 on both sides. We get that x is equal to 9. And we'll do the same thing on example D. The hypotenuse equals the leg times root 2. I know this is a 45, 45, 90 because 45 and 45 is 90. That leaves 90 degrees for the other angle. So the hypotenuse 10 is equal to the leg, which let's call that y, times root 2. So I divide root 2 on both sides. Now I cannot leave a radical on the bottom of a fraction. That's not its simplest form, so we need to rationalize the denominator. I'm going to multiply by root 2 over root 2 so that the bottom is no longer a radical. I have 10 root 2 over root 2 times root 2, which is 2. And then I can see that 2 goes into 10, and they're both outside the radical, so I can do that. So finally, it would equal 5 root 2. Alright, so here is a problem for you to try on your own. Find the value of x. Pause the video now. So hopefully you got that x was equal to 4, because 2 root 2 times root 2 comes out to 4. All right, one more for you to try on your own. Find the value of x in this triangle. Go ahead and pause the video now. All right, so for this one, we had the hypotenuse equals the leg times root 2, so 5 equals x root 2. Divide out the root 2 on both sides, and we get 5 over root 2. Can't leave a radical on the bottom, multiply by root 2 over root 2. And so then the final answer would be 5 root 2 over 2. The next type of special right triangle that we have are 30, 60, 90 triangles. And they actually originate from an equilateral triangle. So I have an equilateral triangle here, and I'm going to draw the altitude of that equilateral triangle. When I draw the altitude, I cut the base in half, and I also cut the angle on top in half. So if it was 60 degrees, now it's 30 degrees. And so I have a 30, 60, 90 triangle that's half of my equilateral triangle. Well, if I let the short leg equal x, and my altitude cut the side in half, so that means this half would also be x, then the whole side would be 2x. And so the hypotenuse of my 30, 60, 90 triangle would also be 2x, because it's an equilateral triangle. So it turns out that the hypotenuse is always going to be 2 times the shorter leg. But we don't just have a short leg, we also have a long leg on our 30, 60, 90 triangle, and that's the altitude in this picture. So that's my long leg right there. I'm going to figure out what the relationship is between the long leg and the other two sides. So using the Pythagorean theorem, I know the long leg squared plus x squared has to equal the hypotenuse squared, or 2x squared. So when I square 2x, I get 4x squared, and then I subtract the x squared from both sides, and I get that the long leg squared is equal to 3x squared. So when I take the square root of both sides, I'm left with the long leg equaling x times root 3. So the longer leg is going to be the shorter leg times the square root of 3. So here are 2 more formulas that you must memorize, because again, you're going to be using these a lot, so you want to memorize them. Alright, so now let's use these formulas to solve some problems. Oh, one more thing though before we do that. The extended ratio then of the sides in a 30, 60, 90 triangle, if the short side is 1, then the long leg is root 3, and the hypotenuse is 2. So that's the extended ratio of the sides. Alright, so let's take a look here at some examples. We're going to find the value of the variables for each of these. So the first thing you want to do is stop and think about which one is the short leg and which one is the long leg and which one is the hypotenuse. So when you first start doing these problems, you might want to label them. The short leg is going to be opposite the 30-degree angle, because the shortest side is always opposite the smallest angle. So there's my short leg. Here's my long leg, opposite the 60-degree angles. And of course the hypotenuse is always opposite the right angle. So the hypotenuse is twice the short leg. Two times the short leg. So in this case, y is going to equal 2 times 2 root 3. And then that would just be 4 root 3. And then I'll use the other equation, the long leg equals the short leg times root 3. So long leg equals short leg times root 3. So my long leg x is going to equal my short leg, 2 root 3, times root 3. So root 3 times root 3 would be 3. 3 times 2, x is equal to 6. Alright, and looking at example B, again, I want to label the parts so I don't get mixed up. This is my short leg, this is my long leg, and this is my hypotenuse. So the hypotenuse is equal to 2 times the short leg. So y is equal to 2x. Okay, well I need to find my short leg before I can figure out my hypotenuse. So let's go over here and use the other one. The long leg is the short leg times root 3. So 8 is equal to x times root 3. I divide by root 3 on both sides. And I get x is equal to 8 over root 3. I need to multiply that by root 3 over root 3 to rationalize the denominator. And so I get 8 root 3 over 3. So that's the value for x, 8 root 3 over 3. All right, now I can go back and finish finding y, because it equals 2 times 8 root 3 over 3. And so y will equal 16 root 3 over 3. All right, so on your own, I want you to try and find the value of x and y for this triangle here. Go ahead and pause the video now. All right, so this one you could probably do in your head. X is the long leg, so I just take the short leg times root 3. So x is 4 root 3. And the hypotenuse is twice the short leg, so 2 times 4, y is 8. All right, one last example here. You may have to use your special right triangles to find the height of an equilateral triangle, or eventually find the area also. But for this example, we'll just stop with finding the height. So the first thing I want you to do is draw it, because doing it in your head is just going to more than likely lead to mistakes. So the first thing I'm going to do is draw my equilateral triangle with sides equal to 32. And then I draw the altitude. That's what I'm trying to find. When I draw the altitude, I cut the base in half. So in my picture here, the altitude is actually the longer leg. And of course, the long leg is equal to the short leg times root 3. So my short leg is 16. Therefore, my altitude would be 16 root 3. And then if asked to, you could go on and use this to find the area of the triangle also. But right now we'll just stop with the altitude. And that concludes this lesson. Thank you for watching.